Bismillah. Welcome everyone. This is part 2 of today's unique Cyber Saturday where we ended up solving two intermediate CTF challenges. The first part we've done was the profile page. So that's the one, the XSS into the stored XSS into the cookie exfiltration. And the second one we're going to do is an interesting and unique one, and you're going to see why in a second, which is the stream VS. It has 40 solves currently, so that's an indicator. It's more on the hard side, or more people found it difficult. But let's see if that's actually the case. Because we're going to see that through strict methodology and going systematically about it, approaching the problem systematically, we can end up solving these challenges. And of course, given that the CTF challenge itself is designed well and doesn't have much guessing and doesn't have plenty of room for guesswork. So let's copy this link. We're given that site, and the first thing we notice is it's not a white box test anymore, unlike the previous one. So there will be lots of dev tools, and we'll try to reverse engineer what this application is happening, and we're gonna see in a second. So let's have that open, and the first step in any CTF of that kind is, especially in web applications, is just to use it. Just like go ahead and use the application, see what it does. So right now we have something called StreamVS. Let's actually open the inspector here. And one thing that I noticed right away is this, connected to WS. WS in this context is WebSockets. And we can look that up. So WebSockets is an HTTP standard, a standard based on HTTP that allows for real-time event-driven communication between clients and servers, precisely. And it runs over HTTP. So we perform some HTTP handshake. It's called HTTP upgrade, where we take our HTTP connection and make it a bidirectional, turn it into a bidirectional channel where we can send messages between the client and server in real time in a persistent manner. And then we can close the channel and go on our merry way. So whenever we have real-time applications in the web, it's going to be WebSockets. Most of the time. So let's make this a bit smaller, and let's open the network tab and see what's going on, because I want to, in general, when you're testing a web application, you have source code. You want to see what this application is doing behind the scenes. What endpoints is it hitting? What requests is it setting or sending? What responses is it receiving? That kind of thing, because we're reversing it at that point. So let's try and use this. So I'm going to do type in my username, and then we have two keys. I don't know what that is for. Let's do play. And do we get anything here? Can we refresh maybe? Okay, so we hit play, and we're met with this. There's three options. It seems like we're hosting something. Let's see. Can we host? Okay. And meanwhile, we can see that there's this route here, 101, 101, switching protocols, and this usually indicates WebSockets. Can we look at that? HTTP status code 101. It's basically the... Okay, so it means that the server understands the upgrade header field request and indicates which protocol it is switching to. So just as we've seen in the diagram, we're sending an HTTP upgrade, and the server somehow understands it. So we can look here at the request. So this is the request, And somewhere here, we're gonna find a header called upgrade, and it takes a value of WebSockets. So they created it in a modular way so that HTTP can support different, maybe other protocol upgrades. But the one we're using in this case is gonna be WebSocket. Now let's see what else. The response was upgrade, so we sent upgrade WebSocket, and the server responded back with 101. That is switching protocol, so it's telling us that yes, I do support WebSockets, and it's in this upgrade WebSocket back in the header, and there's something here related to WebSockets, WebSocket accept. I think it's an identifier or something for the socket we're going to be using. We don't need to worry about that. But let's look here at the response tab, and what we can see is we can see the actual WebSocket communications. So the things or the messages being sent over WebSockets, and it's going to look different if you're using Chrome, but here in Firefox it's under network. It's displayed within the response section, and it gives you the data as JSON, and it gives you the time that data was sent at. So, and you can see the connection is closed here. So now if we actually refresh this page, because I'm very interested in this, because I want to see what this application is doing. There's nothing else going on here. There's just the home page static, and there's some JavaScript which we can look at in a second to look at the client-side code. But for now, and let's actually open this. So can we open this here? Yes, let's keep it here. We can look at that. And for now, let's look at this further. Let's refresh. And let's look at the stream from the very start. So when we do play, we sending, so this up is going upstream, is going from us to the server. Type, login, and then the username. Cool. And then it doesn't send the key. It's usually, or like the keys we're using, it's stored client side. And then we get back a confirmation that our login was understood. Now let's do host. So we send up type host, and then we receive a join. Okay, so we receive a game ID. Okay, it seems. And this game ID, it seems like it was understood by the client side, because now we have a URL that we can share with other users. So if I do open link in new tab, we can join. Let's actually open the network tab for this guy as well, and let's refresh as well, and let's look at this. Look here, and we can look at the response tab, and let's now do new user, and let's do play, and we can see that now this guy, he logged in, he received the confirmation, and then he joined. So instead of previously here, what we had to do was host. So after logging in, we hosted something. That second guy, after logging in, he joined this ID, this room ID. And now we can see that they are both in the same room. And we can see that the host has the option to start the game. The other guy doesn't. So it seems to be some game of some sort. And we can do start. And there is some song starting in few seconds. And it's playing. And let's actually mute this. Okay, and we can see that if we press the keys we defined earlier, the Z and X, then there's some ppm, beats per minute score, that is increasing. So maybe the faster you press these keys, the higher your beats per minute. So okay, so some interesting game, and you can see like it compares the okay, it skipped to the next round, but you could see that it's comparing the your score, your beats per minute, with the other users. So it's like do something here and then go the other side and do something here as well, and let's see how that ends. So in 8, 7, 6, 5, 4, 3, 2, let's increase this guy as well, and we can see okay that we got some message here, but you can see that we can see every round, and we can see every user's score in these rounds. So that's interesting. That's very interesting. Let's see what happens if we come here and let's try again. And we have other options, so we can join and we can put in a game ID and join. And there is an option here that says challenge cookiesy. Okay, so you can go against some sort of, maybe an advanced player, maybe it's a bot, but if you start here, you end up going against him at very high beats per minute. So like we can type in stuff, and no matter how hard we try manually, we can see that this guy always is gonna hit 205 ppm. So he hits the song's required beats per minute. So there's no way around him. He's too good. So what can we do about that? Could we possibly automate this game in a way that allows us to beat this super strong opponent? Can we do that? Let's look at let's go here and let's look at the messages that are being sent in this game. So like how is the server getting our inputs? How is it validating them? How does it know that we achieved that score? Okay, so now I think the game is done. 3 songs, and we can see an overview of every round, and we can see that all rounds this guy he hit 205. The song was 205. Here the song was 211.11. He hit 211.11. The song was 182. He hit 182. So this guy can't be human. That's a bot, definitely. I mean, obviously, but it's a bot and it's programmed to match that speed. Now we are human. We're only human, so we're unable to match his speed, and we will never get to end the game this way. So is there a way that we can match this? This is going to be my first line of thought, because so far there's no, I mean, we looked at the requests, there's nothing being sent really apart from the WebSockets traffic. There's no different or weird endpoints. There is no, we looked at the client side, and I did look at like append, so like XSS vulnerable functions. So there's jQuery being used here, and we can see like functions like append being used. We can see things like inner HTML being set, so you can see stuff like this around. So these were like, initially, if you see these kind of stuff, then this could be actual sinks, like DOM sinks for XSS. But the thing is, in this challenge, there's no bot functionality, or there's nothing that we can send to the, like, I mean, compared to the previous challenge where we had an actual interface where we could send a URL or like make someone visit our page. This is just a WebSocket based game where you're interacting. Sure, you could put stuff in here and it can be injected, but we're not even sure whether the other opponent is playing this game through a browser. Maybe since it's a bot, maybe it's just using WebSockets, and it doesn't even care about what messages are being sent. Like, it's not necessarily using this client. So I don't think it's fair or logical to make that assumption that we should focus on an XSS vulnerability here. Instead, I think we should focus on the primary objective, or the special thing in this challenge, which is the WebSockets. Are we clear so far? So, okay, so this is how we narrowed down the attack surface, or the objective of this challenge, to one aspect and one aspect only. So now that we have done that, let's look at this further and let's see what the stream looks like, and let's see if we can replicate it. Because if we replicate it somehow, the this is a full game run here, so we can see it here in the dev console. We log in and then we receive a confirmation. So let's like cycle through these, and then that was our cancelled join attempt. We get an error. Then we decided to challenge, and then we got a message back that of the giving us the game ID, and then we got a we decided to start. So we told the server let's start, and then we received after joining we sent let's start, and then and keep in mind that this is all like one persistent connection. So once you're here, you're identified. You don't have to send an identification or a cookie or anything like that. Once you've logged in, you performed that initial handshake. So now you're a socket in that server. You've logged in as with that username Elmo, and the server recognizes you. Okay, so your data is now like as a client, you're known to the server. So we can just start, tell the server that we're gonna start, and it knows who you are and who you want, like who's trying to start, and is gonna send you some. Let's see. So here we got some stuff, and then here we got some other. After starting, we got some other stuff. So we got another attribute called songs. So it's giving us or telling us about the songs that we're going to be playing. And so right now there's 0, 1, 2. Okay, so there's 3 songs, and each one has a duration, and it has a certain beats per minute. So let's try and reverse engineer this. Where that's actually what we're doing right now. We can see that our clicks are being sent. So the individual clicks are being sent after every round. And then there's something that we look at, and then there's something further. So that's like after we sent our results, our clicks. So like here, we just started and we got told about the songs we're going to be playing, and here we sent our individual clicks from the client side. Now clicks is interesting because that's pretty much what the game is about. Like if we send many clicks somehow, then maybe we can win the game, right? But we can see there's some other stuff as well. So there's something like start time, and we don't know exactly what are these numbers, like how do we determine these numbers. And there's a start time and there's an end time. Okay, cool. And then after, let's just keep these in mind. But after sending our clicks, we receive 2 messages. So we receive our results, or like our results gets confirmed by the server, and then we receive a type game which has information for the upcoming round. And then we play the next round, we send our clicks again, and then we receive the results confirmed by the server, and then we start the next round. And then the third round, we send our clicks, and then our results, and then we get the final conclusion. Better luck next time, because apparently we lost. So let's see if we can now. Like my first intuition would be to try somehow to simulate this, because once we have some working automated script that can do these for us, we can start playing around with it, seeing how different values affect the server, or how the server interacts or responds to different values. So let's do this. I'm gonna go here and I'm gonna cd into my sandbox, and we have the previous challenge, and I'm gonna make one for this called stream vs, and let's cd in here, and let's code solve.py. Okay. Sandbox, or let's actually have free. I mean, if we code. Okay, so now we have a I trust this, and we can do solve. Oops. So we can do solve.py, and here we go. And that's going to be our solver script. Let's zoom in a bit, and let's see if we can actually emulate that. So what is, yeah, we don't need that. Don't save, please. Okay, so the first thing we want to do is we want to communicate in WebSockets. So let's see how's that done. So Python WebSockets, and there's a library. I had it open, and we can look at the PyPy project for it, and we can see this is a server. We can see this as well. Okay, we could use that one, and that's how you do it in WebSockets. So let's get back on track. So that's how we do it. We get a connect function, and we're gonna do ws connect, and we're gonna pass in the URL. So right now the URL is gonna be pretty much this. We can look at the request headers, and we can pick that up. And let's keep that timing out because that's how we're gonna replicate it. And here we go. So now we have connected. Now we're gonna perform now we're connecting to that socket. Now let's see if we can send a login. So I'm gonna do ws.send, and the thing is, when you send like anything that you send here is good, it has to be a string. Okay, so the way we're gonna do this is we're gonna do data, and let's actually specify the data. So it's gonna be type login and data, and let's do Elmo, and we're gonna do JSON.dumps data, and let's import JSON here. So I'm gonna say import JSON and keep that up here, and that's how we do it. Now we want to confirm that we're receiving something back, so I'm going to do r equal ws.receive, and that's it. It's going to pick up the next message received by WebSockets, and we can print that out. So now let's see if we can Python solve.py. Do we get anything? So of course WebSockets is not installed, so what we're going to do is I'm going to do let's check the pip version 2.7, so pip 3. Okay, so pip 3 or Python -3, that's okay. So there's some conflict here. Okay, Python 3 m and venv. So let's create a virtual environment here. Package using the following command. Intrubib is not available. Why is that? Okay. So let's make sure that we have the Python 3 venv or virtual environment package. We created the virtual environment, and we're going to activate it. So I'm going to do source venv bin activate, which took some time, struggled with that. And then we're going to do Python, and that's now the Python within the, supposedly, within the virtual environment. Can we check that? pip-v. Yes, that's coming exactly from the virtual environment. So I can do pip, and I can do install, and I can do WebSockets. Okay. So now that we have installed WebSockets, we'll be able to run our solver script. So we can do solve.py, and we can see that we received type login back. And actually what we should do is at the very end we can do ws.close. Okay, so now if we cancel this and run that again, here we go. Let's keep that all the way down here. And now we've confirmed that we're able to issue a login command and we're able to receive a confirmation. So we can keep this block together. So that's going to be called login. And yes, so that's our login here. And let's do something else. What do we need to do? We need to issue a challenge request, right? So we need to issue a challenge request. And let's copy this message and oops, and it's going to be here. And actually we can copy this, so like we can do copy this and we can do data equal, and here we go. So let's keep this one here. That's actually because we don't have to really act on the, let's print this directly. And let's maybe give it a number. So now we did the first step, we logged in. Now challenge request, actually we don't need to, it's self-commenting or self-documenting code, can keep it here. So that's one. Now we're sending a challenge, and what do we receive back from the challenge? We receive some game ID. So let's save that game ID. So we're getting back the challenge. Now I need the response from this challenge. So I'm going to do JSON.loads to read that JSON string, because ws.receive gives us a JSON string. So we want to load it, and we're going to do something like game ID is equal to our data. And we can look at this. So our data, and then within data we have game ID. So we have game ID, I believe this was capital. Yes, it was. So, and we can now print game ID. Do we have, so can we run this? Okay, so now we were able to log in, and we're receiving a game ID. And let's actually remove this, because we're not going to be consistent with that. So now we sent the we received the game ID and we have it stored. Now let's actually start the game. So let's copy this and let's start the game. So I'm gonna copy this message. DevTools is being very, very useful here. And let's see what we get. So if we run this, we were not printing anything. Printing R. Okay, here we go. So now we log in, we request a challenge, and we receive the game ID for that challenge, and then we decide to start, and we receive the receive all of this, pretty much all the information we need to know about the game that we're about to start. So actually I think we could have, we don't need to store the game ID here even, so we can just do this. We don't even need to confirm. Maybe just for troubleshooting. Okay, obviously. Okay, here we go. So we log in, and then we join, or we challenge. We send a challenge, and we get a confirmation using that join, and then we start the game, and we receive a confirmation that this is the game that you're gonna start. So now the game is composed of a couple of songs. So let's bring these over. So I'm gonna do songs is equal to our data and songs, and we can print these songs. So we can see here that this is, can you see the output down here? Is it clear? Okay, excellent. And we logged in, we received the confirmation for the challenge, and we got our songs back. That's pretty cool. Now what we're interested in is, after receiving these songs, let's try to, like, this is the step we're at. We started a game, we got the songs back, and now we wanna upload our results. Okay, so we wanna upload our results. So let's upload some results. So I'm gonna do, let's actually copy this. So how does it look like? It says type results and then some data. So okay, so type is going to be results. Let's actually replace all single quotes with well, all double quotes with single quotes here. Be consistent. And then we have data, and we have, what do we have within this? We have data, we have clicks, and we have start, and we have end. So we have, so let's bring this down here. We have data, and that data is going to have a couple of things. So we're going to have it's going to be an object first of all, and it's going to have clicks, and these are going to be some numbers. We don't know how yet, but let's keep them this way. And start, let's keep this as a number as well, and end, let's keep this as a number as well. So now we got that data and we're sending it, and let's see what do we receive back. Okay, so let's see what we receive back. Let's keep this up here because that's associated with that, and let's keep like every step separate from the other by 2 spaces so we don't get confused. And let's print the response and see what happens. So we log in, we join, and then we send our clicks, our results, and we get this. The start and the end time are incorrect. Okay, so how do we make them correct? Let's see what happens here. So in this, the way this client sends the start data, so let's look at this, because when this client sent the clicks and the start and the end, it received a confirmation. So the server approved of its results. So it has to be doing something right. Okay, so let's look at this. So it seems like the start time is a timestamp. So let's copy, maybe this is a timestamp. And did we actually get a, okay, so we did get a start timer in the previous. Okay, so when we decided to start, we got a confirmation that contained a start timestamp, but we're not actually reusing that. So we're using a different, like this start 9064 comes after this 885252. So it comes after it. So I don't think they need to match that. It seems like it. So let's get a timestamp, right? So I'm gonna do from time, import time, and I think we can do something like time millisecond. I'm not sure if Python has a utility for that already. Python time in timestamp millisecond. Does it have it already? Okay, it doesn't. So we have to do this manually. So Let's build ourselves a utility to do this. So lambda, and is gonna just lambda with no arguments, and it's gonna do time. It's gonna do int time times 1000. Okay, because Python timestamps are in seconds, JavaScript timestamps are in milliseconds. So this is going to be a lambda that we're going to use, or we can do, I mean, we can call it any other name, but let's do this time milliseconds. So now let's do start time milliseconds. Yes. Time, did we, oh yeah, that's a mistake. So we need to call time. Thanks. So we have this lambda and we have time milliseconds. Let's look at that. Now let's run this. See what do we get. Okay, it says, I want to see the data that we have sent. So let's do print data. And let's like highlight it a little bit, because that's the data we're sending. So we can see here that we're sending a start time and the end time doesn't seem correct. So that's actually, I mean, obviously I think it does some sort of validation. This end doesn't seem to be related at all to this start. So let's do this. Let's do start is equal to time millisecond or lambda, and end, let's do like start plus some time, so maybe like 1000 milliseconds. So let's do end, and let's do start. Now if we run this, it is still incorrect. Maybe the round, this round, like let's actually look at this. So again, we're reverse engineering what's happening here. So after sending the clicks and the start and the time, let's actually see the difference between this and that. So Control C. Let's I mean, we can do quick terminal here. Okay. Okay, so we have something like this here, and we can do, or we can actually do it here, and we can do this and subtract the time from it. And what do we get? Let's actually divide the result. So let's take this and let's echo this and divide that by 1000 milliseconds, and we get 16. So it is 16 seconds. Now, is this 16 seconds between the start and end? Is it something special? Let's look at this. Let's look at the response, or the server response that we just received before that. Let's look at that. And we noticed something. We noticed that the song that the first song received has a duration of 17 seconds. And there is a start offset as well. So it seems like, okay, so it seems like it is taking this duration, and let's just take this duration. Let's take this duration. So let's do songs 0, the first song, and let's take its duration. And that duration is in what? It is in seconds. So let's convert it to milliseconds. Let's run this again. And we're making progress. Like we moved one step ahead, right? Like that actually did work. We sent this data with that start and end, and we didn't get the error anymore. Now we actually like we actually did move to we got confirmed, like our results got confirmed and passed that step. So let's actually do this for the in a loop, right? So we need to loop and do this again. So I'm gonna do a for loop. So for I in I mean, we can do for yeah, let's do that in, because because I want to keep the index with me. Or we can, I mean, for simplicity, we can do is and enumerate songs, and let's put that whole thing in a loop. So for every song we're gonna start, and for every song we're gonna send some results, right? And for every song we're gonna receive the output back. So let's do this. See what do we get. The start, and so there's something wrong here. I think so. I think we messed up something. So once you send your results up, okay, you perform two receives. You receive two things. So you receive the results, a confirmation for your results, and then you receive um, game information. Okay, you receive the game information. So maybe we need to do ws. So print r dot print ws dot receive again. So let's do this. So now we're doing that. I mean, you can. What was it? Alt Shift. I forgot the shortcut. Control Shift. No. What was the shortcut? No. No. That's what happens to you when you stop using VS Code and use Vim. Command palette. No, there's a shortcut for with the arrow keys. So duplicate line, VS Code. I think Alt Shift, Control. Oh, all of them. Control Shift Alt. Okay. Wait, what? No. No. Shift Alt. Wait, there's something totally off here. Shift Alt Up. Yeah, Shift Alt Up. I think that should work. Control Shift D. Alt Shift D. Okay, never mind. Look what you're gonna do. We're gonna do this. Best way. Yes, fail proof. Okay, so I think it's something with the Kali key maps, because I think that works on Windows normally. Okay, so now if we run this, what's happening? Okay, we got the start and end timings are incorrect. Did we get that for all of them? So, no. Just, we got an error for one of them. So, maybe we do really need to account for the start offset. Is that a thing? So, duration. So we can do, oh, we forgot to do this. Okay, so now I believe we should get no errors. So we send the first results, and it got confirmed, and we sent, yes, so that's correct, and we got better luck next time. So let's go back here and let's look at this. So we, at the very end, when you send results, you get your message here, better luck next time. Now let's see what is happening here. So what's happening here? So we sent, let's look at this, let's expand this further. Let's make this bigger and let's review this, what we have so far. So we logged in, we got confirmation, we got the game, we decided to start. So when we started, we got our that's when we decided to start. So when we start, we get the game, and then we send some results, and we get a confirmation for these results, and then we get game information. So what's gonna, like, what's the next round about? And then we get again, we send results again here, and then we get confirmation, and we get the game. Now we send the results again, we get a confirmation. This is the confirmation, and we get a message, better luck next time. Now I don't know where this comes from. I think it's an extra print. Yes, it's an extra print that we did have. So now if we run this again, we should end up on a better luck next time. It's taking time because the bot on the other end is assumably playing the game as well. So better luck next time. Here we go. Cool. So now we need to look further into the actual things that we're sending. So right now we can see here that the data, what's the data we're sending? So this is the data we're sending. Clicks 1, 2, 3. Start and time are correct. Start and end, because we are not getting the error anymore. Instead, our results are getting accepted. But if we look here within the results, we can see that that user, Cookiesy, has ppm of 184. That's his score. And we have a ppm of 3.75. So we are pretty much, and I think this is an ordered list of who won, something like that. Oh no, I think these are the scores for the entire for all rounds, for all users in all rounds. So that it seems like we lost. He got 188. The song required 188. Go ahead, Omar. Add new lines between responses. Yes, yes. So let's do this. So so we're printing the data. Let's add a new line here, new line there. And let's actually not print the unnecessary data. What data is unnecessary for us? Let's actually, can we do this? Let's add some coloring. So let's add it to the results, game results. So red, and I believe you need to, from rich, import rich okay. So so we import print and then we use their print. Okay, so we just import print and it's going to overshadow the print that we have. That's as simple as that. Now I think if we run this, wow, okay, that's nice. So it does automatically pretty print the like objects for you. Wow, that's much better. So, and I think the red color did not, well, I think we need to wrap it in red color. So, right, like we need to do this. No. italic red. Okay, it's a BB code, like the previous challenge. Doesn't match any open tag. How is that? Printing. Oh, maybe you cannot. Probably you cannot do it this way, so you need to do something like this. For it to work. Yes. Okay. Okay, nice. So we're printing the result confirmation back in red. So you can see here how now we log in, we get the challenge, we said that many times, we get the songs that we need to play, and we get their ppms, their duration, and that's how we fake the start and end times, because we as we've noticed, there's no server-side validation on these, so the server just makes sure that that information matches with the challenge given, but it doesn't actually check whether the time was actually spent. It doesn't. There's no confirmation whether the clicks were actually sent. It's actually difficult to do that process, and that's why games many times get hacked easily. It's because you need to balance between real-time client-side execution and server-side validation, and like the integrity of the data that's being supplied to the server, which is not easy. Which is kind of what this challenge is about. Now, when we send our results with the fake start and end and clicks, we get confirmation back with that information, and we can see that our ppm is always falling behind the Kokisi bot. So Kokisi always gets 184. He got 184 here because the first song had 184, required 184 BPM. And actually these songs change. So if we run this again, we're gonna have different songs with different BPMs with different durations. So let's see how can we supply an accurate ppm. Okay. Let's see how can we do that. For this, I'm gonna resort to the source code, the client-side source code, to see how does it. Because here in this code, in this communication stream, we can see that the user is sending a number of clicks, and it is receiving the what does it receive? It receives here in this game. It receives the BPM of these clicks. Where is the I mean, at least that's the one we have here exactly. So it receives the BPMs, or the BPMs for these clicks gets calculated somehow. So let's actually try adding, like, maybe let's add a loop here. So range 100. Let's do like a very big number. Would that work? Okay, it's not serializable, so let's do, let's convert it to a list. It's an iterable, but it's not a serializable object. Oh, okay, I think I put a little bit too many. It's taking some time. Maybe that's too many as well. Okay, so we I think I would expect my BPM. Okay, so my BPM did actually skyrocket here. We got 6. Okay, we got 6.5. Okay, so we're beating this guy. Would that work? Okay. So that did not work. So it seems like there's no point exceeding the BPM of a song because it's about the rhythm, I guess. So you have to match the BPM of the or the beats per minute for that song. You can just put some arbitrary number. But at least we know something, that we know that there's no validation whatsoever on the number of clicks we supply, and that we know that these numbers now do not matter, so we can send anything. It's just the number of clicks that is considered by the server. So we need to send the right number of clicks per song, and that's how we will somehow get our flag, maybe. So let's do like let's put some, random number for I in range, and there's some mystery number here. So that's gonna be the number of clicks. Okay, let's call it number or click count. Okay, so we need to figure that out, and we're gonna figure it out here. So click count is equal what? Let's look at the, and first of all, we need that click count to match the BPM. So I think this is going to be a function of the BPM. Okay, it's going to be a function of the BPM. So we can actually do BPM to clicks. And now we need to figure out that function. Once we figure that function, we're all set. Let's go here, and we're going to have a BPM to clicks, and it's going to be another lambda that takes in BPM and returns the number of clicks. Let's go to the client source code, and let's see if there's a formula or something that helps us calculate the number of clicks, or maybe the BPM, or any like relation between the two whatsoever. So BPM, let's look for that. There's something here, BPM standard deviation. How did this? Okay, we have something here actually. We have this algorithm here, and oh, it seems to be something that is known, I guess. We can look that up. And okay, not that much, but let's look at this. So it seems like BPM math.round. So it seems like BPM is precisely a function of the number of clicks. Yes, I keep forgetting that. Okay, so now that we're looking, we can find that BPM is precisely a function of the number of clicks. Click array is the clicks that we sent out as a client. Let's actually copy that here, and let's go to Visual Studio Code, and let's add that here as a comment. Okay, and let's see if we can actually reverse this. I mean, that's now elementary algebra at this point. So the math.round is going to take some numbers out. I think we can ignore it for now. So I think I can do clicks count is going to be equal to, let's like slowly reverse this. So I'm going to do ppm times 100. That's the first thing. Moving that to the other side. And then this is math.round. It's only an off by 1 error, I would say, in most of the cases. So let's actually ignore it. Okay. And then we have this times 1000. So when we flip it, it's going to be divided by 1000. That cancels, so we can remove that safely. And then we're going to have this inner thingy, so multiply by 4. And then we're going to divide by 60,000. Okay. And then we're going to multiply by end minus start. So we're going to do multiply by end minus start. And that's going to give us the click array length. At least it should. Reversed, if inverse. And if we paste that in here, Maybe you can give it the duration, because that's end minus start, is it? Yeah, it is the duration. And is this in milliseconds or? Yeah, I think it should be in milliseconds. So if we go, so that's the duration pretty much, duration. And number of clicks should be an integer, so let's wrap that all in an int. So let's go all the way down here and BPM to clicks, and let's give it the, let's actually give it end minus start here. And let's hope for the best. Let's run that. Okay, something is wrong with the beats per minute. Okay, so BPM is going to be grabbed from the song. So songs I and BPM. Let's run that again. And we received something. Oh, that's the results. So 1 second. So the BPM for our BPM is 197.37. So oh, okay. 1 second. 1 second. Let's hold on. So there's plenty of stuff. Let's actually not print the. Let's not print the like this, like what we send, because it takes lots of space. So okay, so the first song here has a BPM of 188, and we sent 180. Oh, so we sent actual accurate clicks that has 187.5. Okay, and here we go, and we get the flag. So there's some, you can see that that's Uso, are you a robot? So you can see that there's some like rounding errors. So there's some rounding mistakes because of the math.round that we've ignored. 187.5 while the actual value should be 188. So that makes our solution a little bit non-deterministic. It's not going to always work. You need to run it a couple of times and hope for numbers that do not give you decimals. But let's see. So for example, in this second song, we got a BPM of 190 and the bot got a BPM of 190, and the song did require a BPM of 190 here. So indeed we are on the right track. So we're writing the BPM. So for example here, this is last song required 200 BPM, and we did get 200 BPM, did we? We got 199.77. So maybe we need to do something like maybe math.ceil. So here, for example, ceil instead of int. And you know how we can do that? We can do int. And that's a trick to do sealing without. I think this should make us win. So that's 200. No, I think that didn't work quite. No, that didn't work. Why not? Okay, anyways. No way, I think I'm not sure, to be honest. But this does work. So we're able to forge requests that gets us to negative should surround everything inside. No, it shouldn't. It's multiplication and division. So here we go. We keep getting it's pretty reliable. But for some values, so I'm getting 199.74. I think mainly because this is calculated by the server. It's not calculated by us. Like we created some number of clicks that might get us the number we want. So maybe that's why. But yeah, that's pretty much it. What do you think? We can take that and submit it as our flag. And if we want, we can, what can we can come here and maybe at the very end, so maybe we can, let's actually like quickly automate this, so we can stop everything, all prints, so print, and let's actually do regex and take prints at the beginning of a line and replace them with a, like, comment them out. I think that was the last print that we had. And then what we can do, okay, so there's some, okay, there's one here, and maybe we can do a capturing group. We're doing programming here, so we capture this in a group, and we can do one. Would that work? Oh, we need to, oops, we need to capture everything within. So if we replace, yes, it did work. We added the hashtag before this. So now what we can do is take all of this. So this is from the second we log in. Oops. Second we log in, and we can indent it, and we're having a challenge. That's our function. And what we can do is we can say something like while, so, or maybe, how can we do this? I want to automate this. So when we send this, and maybe here we can return this result. Oops, no, we cannot return it here. We can, so maybe we can have R, and we can say that R is equal to this, and we can say that we want to return R. Okay, let's keep these here. So let's return R, and let's do while USO not in challenge. Pass, and maybe we'll need to print it as well. So how do we do this? So okay, I mean, I want to do it in the least amount of lines possible. So KR we're doing some magic stuff now. We're gonna load R, and we're gonna take in the data, and what did the flag look like? So 1, 2, 3. I mean, we don't want to count this, but we have 4, 5, 6, 7, 8, 9, 10. So 11. If this is correct, I'm gonna be very happy. So now this should be our key data error. I don't think we're reusing. Maybe this is causing some confusion. I don't think it is, but maybe. Okay, yeah, it's not. I think it's about resetting the connection. And this can be R, can be R, can be R, can be R. Line 30. So line 30, that's line 30. So why are we failing? R is equal to JSON dot loads. Do we have to await something? Maybe again this is the issue. Let's see what's received here. So let's print R. Let's see what do we have. Type is login. Did we? I think we need to remove this. So for some reason, oh, okay, that's very stupid on my side. So just these prints, they included the actual. Okay, we don't need this. We can keep this up here, no problem. It's just one connection that we can use for all of these. And the print did include the, at least some of the prints did include the receive. So ws.receive, we need that here as well. So yeah, now we're good. And we can keep this all the way at the end. And we don't need to, we can reuse the R variable, no problem, because it's a different scope. So now if we send this, while also is not in R, type is not iterable. So why is it, why do we have non-type here? This is correct. And we don't need it. But let's see, why is that not iterable? So okay, when we send, we don't really need anything back, but we need R to be equal to ws.receive. And I think we do need to R equal ws.receive twice. So bismillah. So this is gonna repeat the script until it finds the flag. What? Oh, okay. So, okay, the other way around. So we got nice job and the other way around. So this is gonna be 10. So we got the useless part. Now we're waiting. Will it work? Here we go. So now we have a deterministic script that's always going to give you the flag. Right, thank you guys for watching. Hopefully you enjoyed it. I did enjoy it, and see you in the next one.